Okay, for homework, you guys had 7.6 practice C. You had the odds. So there's number 1, the answer for it. There's your answer for number 3. Number 7. Number 9. And then number 13 and 19 are both there. And number 15 and 21 are both there. And then number 23 was no solution. And then number 28 looks like this. And there's your solution. All right, as for the height was 4, but you really had to do all this work in order to find that. All right, so now for today. We are doing the 8.1 notes, 8.1 and 8.2. This is on exponential growth and exponential decay. All right, you have to be able to tell the difference between exponential growth and exponential decay. That's one thing on the test that you're going to see. They're going to ask you if something's exponential growth or exponential decay. All right, so exponential functions have the variable as an exponent. So for instance, f of x equals 2 to the x power. That is an exponential function. All right, the 2 would be the base and the x is the exponent. So you're looking for, this time, the variable is in the exponent, and that's what makes it an exponential function. All right. Now, the way to tell whether it's exponential decay or exponential growth is basically you look at the base. If the base is greater than 1, the function is exponential growth. If the base is between 0 and 1, the function is exponential decay. Okay? So, these are some examples of exponential growth models. Again, it's an exponential growth model because there's our exponent and their base is 3. 3 is bigger than 1, so that is exponential growth. All right? Again, for B, we find our exponent of x. We look at the base. The base is 3 halves. 3 halves is 1.5, so it's bigger than 1. So those are exponential growth models. All right? When you graph them, exponential growths grow away from the x-axis. So they go something like that. This one, though, because it's negative, it's going to grow away from the x-axis in the negative direction. So it's going to look like that. All right? So this one will look something like that. This one, because it's negative, will look something like that. All right? And then we got exponential decay models. Again, you locate your x, or your variable. The number beside it is the base. The base is less than 1 or between 0 and 1. So this one is exponential decay. B is sort of our trick question that you have to look out for. All right? So when you're looking at B, you got to worry about that negative sign. If there's a negative sign in front of the x, then you have to simplify this. Now what you have to do is distribute this basically to what's inside here, and a negative sign as an exponent, all it tells you to do is flip the fraction on the inside. So this problem is actually looks like this. All right, that's how it should look, and that is why that is exponential decay. All right, so in real life you are going to see exponential growth and exponential decay models. An example of an exponential growth model would be compound interest. This is your compound interest formula. A equals P times the quantity 1 plus R over N to the nth power. Now P is the principal, R is the rate. This N and this N are the same, and they are both the number of compoundings. Compoundings means how often you're going to charge interest or you're going to get interest. All right? And that is the number of times. That N stands for the number of times per year. All right? So if it's annual, that would be a 1. If it was daily, that would be a 365. If it was weekly, that would be a 52. If it was monthly, that would be a 12. All right, so that's what that N stands for. And then T is the time, and that is the time in years. So that is one formula we're going to need, our compound interest formula. And again, that's exponential growth. All right, the next one we have quantity decreased by fixed percent. This is an exponential decay model. All right, this is also called depreciation. All right, it's how something decreases in value over time. All right, if you're planning on owning a small business, this formula will be helpful because you can take your depreciation off from your taxes, all right, which will save you money. For instance, if you have a landscaping business and you buy a truck and you buy lawnmowers and you buy blowers and everything else, all of that stuff that you buy for your company, you can subtract the depreciation. You can take that off on your taxes so it can save you some money. All right, but this is the depreciation model. A, again, is the original amount that the item cost or was worth. All right, the new value, the original value, I mean. All right, R is the rate, and again, it's going to be, they'll give it to you as a percent, but you need to change that to a decimal. And then T is in time, and that is in years. All right, so how does this stuff work? All right, so example 3. We're going to deposit $1,000 into an account that pays 8% annual interest. Find the balance after 1 year if the interest is compounded with a given frequency. All right, so annually, that means that our N equals 1. So our formula looks like this. A equals P, the principal, which is $1,000, times 1 plus R. The rate is 8%. We have to change that to a decimal, so it's going to be 0.08. 0.08 over N. And again, N was our number of compounds. It's just 1. All right. And then times the D, or to the NT power. So it's 1 times, and let's see, balance after 1 year. So the year is also 1. All right, so it's going to look like this when I simplify it. We have 1,000 times 0.08 divided by 1 is 0.08. 0.08 plus 1 is 1.08, so it's 1.08. And 1 times 1 is just 1, so it's just going to be a 1 there. So really we just have 1,000 times 1.08, which actually just moves the decimal place over 3 places. So it's going to be $1,080. So after 1 year, if you get 8% interest, you would have $1,080. Right? So you would make $80 interest, but the total is what they give you. The total amount of money you have would be $1,080. All right. 2. Now we're going to talk about quarterly. Quarterly means 4 times a year. So this means that N equals 4. All right, so same formula. Everything else is the same. So we got A equals 1,001 plus 0.08. This time the N is 4. And again, 4 times 1. So now we simplify this. We get A equals 1,000 times 1 plus 0.08 divided by 4. 4 times 1 is 4, so that's all I really simplified. Now I'm just going to put it in my calculator. All right, so putting it in the calculator, I, again, would do this step by step, all right, when you're doing this, all right? So what I do is this. I start inside the parentheses, so I would do 0.08, divide it by 4, hit enter. Then I would do plus 1, hit enter. And then I would do to the 4th power, hit enter, and then times 1,000. And hit enter, and there's our answer. So now we have our A is going to be $1,082.43. So if we got, instead of getting annual interest, we got our interest quarterly, we would get ourselves an extra $2.43, right? And then number 3, they're changing it to daily. Daily, again, means that N is going to be 365. So our formula looks like this. A equals 1,000 times 1 plus 0.08 divided by 365 to the 365 times 1. All right. So again, I would just do the 365 times 1, get 365, and then just put it in the calculator. So again, in the calculator, it's going to look like this. I'll clear the other one out. We got 0.08 divided by 365. Enter. So again, I do this first. Then plus 1. Enter. Then to the 365 power. So to the 365 power. Enter. And then times 1,000. And enter. And now we got A equals $1,083.27. Now banks truncate, they don't round. So they wouldn't round that up, they would just truncate it off and give you $183.27. So if we got our interest daily instead of quarterly, it gives us an extra, or gives us $3.27 total. All right. So we went from getting $80 to $82.43 to $83.27, and we didn't really have to do any work. We just had to ask them to compound it different ways, annually, quarterly, or daily. All right. So that was our compound interest exponential growth model. You will see these problems again on the next quiz, on the test. All right. The next one. This is our exponential decay. All right, this is how it works. You buy a brand new car for $24,000. The value of the car decreases by 16% each year. Okay, write an exponential decay model. All right, so let's do this first part. All right, it says write an exponential decay model for the value of the car. So that model is going after this. All right, so we're just using this formula. So I got Y equals A is the price of the car. It was new, 24,000 times 1 minus the rate, 16%. So we have to change it to a decimal, so 0.16. All right, and to the t power. So that is our exponential model. Don't leave it like this on the quiz or test. I will take points off because you should be able to take 1 minus 0.16. All right, so we get Y equals 24,000 times 0.84 to the t power. And you should know it's exponential decay because this number is less than 1. It's between 0 and 1. All right, so that was the first part of this problem. The second part says then estimate its value after 2 years. So now we're going to put a 2 in there. So we got Y equals 24,000 0.84 to the second power. And again, I just break out the calculator, clear this out, and for this we can just put it in there. Well, we can do 0.84 to the second power, enter, and then do times 24,000 and hit enter, and our $24,000 car after 2 years is now only worth $16,934.40. All right, so that's how much. Now it says graph this and estimate how long it will take to lose half its value. I'm not going to make you graph it, but what I am going to have you do is actually put it in the graphing calculator. You put this formula in the graphing calculator and you find this answer out. So the way we do it is this. I'll clear that out. Go to Y equals. Clear that out. All right, and we're just going to put in this formula that we have. So I got 24,000 parenthesis 0.84 to the x power. All right, so that is 24,000. All right, 0.84 to the x power. All right, now the way we get our answer is this. We just hit second and the table. And again, we're looking for when it time it takes to lose half of its value. So 24,000, half of that will be, we want to know when it's worth 12,000. Well, all I got to do is look at my table, and then I can, oh, I was way down on this. All right, so I'm going up. And let's see. Here we go. 11,949 is almost 12,000. So that was 4 years. So approximately 4 years. All right. And that's how you do those problems. All right, so there wasn't any homework for this part of the notes.